Okay, thank you. As Alexander introduced, I'm Michael Bandor with the Software Engineering Institute at Carnegie Mellon University. This welcome to be here. I'm in San Antonio, Texas presently. This talk is looking at a use case and prototype implementation we did for a Department of Defense client. And let's go to the next slide. So the problem space, we do a lot of work with the U.S. Department of Defense, and we had a customer that was struggling to identify software obsolescence issues. They were finding things were expiring when they least expected it, when they thought they had a handle on it. There were secondary and tertiary effects of things breaking. They would find that the hard way. We'd upgrade this particular product and the upgrade would die on them because there was a dependency on another product or a dependency further on downstream. The contractor that was doing the work for this customer was tracking the information across several databases and providing an updated spreadsheet once a month of what it was tracking. The tendency for a lot of DoD customers and people in general is you go with the tool you got, so they dropped into spreadsheet mode. Not necessarily a bad thing, but you don't get the additional insights into the relationships of the data and how things are going to cause those ripple effects. So what we looked at doing was doing a prototype implementation using Neo4j to ingest that contractor data and to start creating some knowledge graphs so you could start understanding those relationships and where clusters of things were happening that they weren't necessarily visible in those spreadsheets. So problem space, tracking commercial off-the-shelf software, COTS, government off-the-shelf software, GOTS, and free and open source software, tracking those obsolescence issues and vulnerabilities in software-intensive systems. So we started asking questions. What's affected? When is the product they're using no longer supported? What's the immediate impact? What are those secondary and tertiary dependencies on my system? Where are the products located in my system and what environments? Are there any impacts from identified vulnerabilities, the common vulnerability enumerations, for example? And how do we track all of this? As I said earlier, organizations tend to drop into the tools they have most commonly available, typically a spreadsheet. So they had looked at trying to use a design structure matrix or dependency structure matrix, depending on which school you follow, which gave them an A and a B, but it didn't give them the secondary and tertiary dependencies. And they quickly figured out that that was not going to work. Real quick, graph 101. We know everything's connected in a graph. We built a property graph using the nodes and relationships. Nodes are the entities, so those were representing the objects of interest in this case, and the relationships between those entities. This is, again, graph 101 type work, if you've had any of the Neo4j graph introductions. Real quick example, a person works for a company, company's located in a city, you've got your nodes, you've got your relationships and properties in those nodes. So looking at the data they had, we started to figure out, answering the question, what information needs to be tracked. So every product has a name and a version. A company, obviously, they created it. There's an end of support date for that particular product. There's an end of extended support date, an end of life. So I'm going to expire, but I can keep working on you for a little bit longer, which is your extended support date, and then end of life date. No, it's a dead product of that. What category is it? They were interested in what's COTS, GOTS, and FOSS. Any possible dependencies on other products, what operating systems it runs on. They were operating multiple operating systems for this particular system. They may have had some of their obsolescence of the products go through a formal obsolescence evaluation process, and it may have one or more vulnerabilities. So we also looked at it from an operating system perspective. You still have same ideas with name and version, manufacturer, end of support, end of extended support. So the difference between the product And an operating system change has a much greater impact on your system than a single product. So initially, when we went into this, we were leaning towards tracking the operating systems as a separate entity or node. You'll see we changed our mind slightly on that. So how we defined it, we have a product. It runs on an operating system node, may depend on another product. It's created by a company with a created by relationship. If it's got an obsolescence issue that's been formally done, it's represented with a has relationship, and it's tracked to a node that has their JIRA information where they're tracking those tickets. May contain one or more vulnerabilities, contains relationship, it's installed in one or more environments. So where is it? Checking the vulnerability. So it's checking those boxes and those questions that we're asking. Similar idea on the operating systems. And then I talked a little bit about the obsolescence issue. We intentionally did that as a separate node because it does have a link. It could drop right into their JIRA ticket. Now, there could be, the way we found out, their JIRA tickets and their obsolescence process, it wasn't necessarily one JIRA ticket to one product. You could have one JIRA ticket covering multiple products, or one product was under multiple JIRA tickets, depending on which environment it had been installed in. They also had some risk categorization that was contained within that JIRA information. So our initial stab at the modeling. So here's the product, and then it depends on other products. That relationship was there. Where it's installed, created by a company, has an obsolescence issue, runs on an operating system, contains a vulnerability. And if you look, these are basically mirror images if you go diagonally. And you'll see why in a little bit. This is why we rethought this operating system note a little bit. So we came up with some possible use cases for this particular customer. Keep in mind, this is Department of Defense, the military system. So they're asking things like, manufacturer announces that software product will no longer be supported. What are the impacts to the system? We got notified of a vulnerability in a product. Where is it, so we can determine the risk to the system? What do we need to do to eliminate or mitigate the vulnerability? Company sells the product to a foreign company. That's of great interest to the Department of Defense for obvious reasons. Again, answering the question, where is this in the system? What's the impact? If they needed to stand up a new test environment, for example, we needed to duplicate an environment, what products need to be installed in that environment? Or if there's a newer version of the product, is there anything to keep us from upgrading those dependencies? So what we ended up doing after looking and playing with the data a little bit, we ended up coming up with this model. Again, it's very similar to the initial concept. So the main difference is this node now has two labels, product and operating system, where they're keeping the OS as a separate node on its own. So you have a software category. There's your COTS products, your GOTS products, your FOSS. Your company's still there, which platform it was installed on. If it has an obsolescence issue, still links to the JIRA tickets, and that can link to whatever platform. Now, what wasn't discussed is this in the support node. So we'll talk about this a little bit later. This allowed us to do some interesting clustering of the data that was not readily apparent in those spreadsheets. So the implementation, we had several goals. We were going to use the existing data source, that spreadsheet that came from the contractor. We did not want to cause a contract change just to accommodate a different data format. In a perfect world, they would have been ingesting this live from the databases and not have to go through a spreadsheet as an intermediate product. But it worked well for both sides, so we left it the way it was. The government customer would ingest the spreadsheet each month, which is their standard process. They would get a normal delivery. The government customer would perform the analysis. This does not preclude the contractor from doing the analysis, but the government would be the one that would be doing the analysis and getting back with the contractor. Part of the prototype implementation, we would provide the installation instructions, the model details, all the documentation. the use case scenarios with examples, the cipher scripts, and the primary script for the initial data ingest and the updates. And we want to try to make this as easy to use as possible. The customer side on the government had never been exposed to graph databases. And when we started doing some prototype with some actual data, they got really, really excited that this is answering questions in real time that it would take them weeks to figure out. So the implementation steps we took, we had to dig through the data because it was coming from 3 different databases. We had to figure out, okay, this is represented different ways. How is this data being used and what is it being used for? It turned out there were only about a dozen columns out of the 60 some odd columns that were actually being used to make decisions. Developed, refined the model, did some small test sample imports to make sure we got the logic correct. Based on those tests, started building the ingest script using APOC with the spreadsheet. Love APOC. That really simplified things a lot for us. We had to figure out, because of the human side of things, how to handle those data entry errors. For example, empty fields that are indexed for performance, empty date fields, typographical errors on some data elements, and date representation. Had to figure out how they wanted to handle that. So again, we tried to make it as easy as possible for the government customer. Go back, confirm the import, subsequent graph was correct, a little bit more refinement, refine the model as needed. That's where we started to decide operating systems don't need to be their own node. Let's take advantage of the fact you can put more than one node label on a node. Implement those, and we decided, okay, how do we've done an ingest, well, great. How do we handle the next month's ingest? Do we want to wipe and reload? Do we want to keep it and do updates? How do we figure out what's new, what hasn't been changed? So I had to think about that logic. And the more we started looking at an update script versus the initial ingest script, it turned out that it's the same script. We had to do some calls with the merge statement and cipher that really cleaned things up for us. Again, did some more analyses, proved out the use cases. Are we getting the answers to the use cases we were expecting? And we were. Tuned the script just a little bit, thanks to the modeling courses at Neo4j that helped us tune it, make it a little bit better for performance. And then write a lot of support documentation. Again, the government customer had not been exposed to this before, so they were definitely very new to this concept, but they really loved the idea of being able to do this. So what were the results of all this? We took 3 different months of data that was ingested. We ended up with 1,554 nodes total based on the model and how we divided things up. That consisted of 134 different companies, over 1,000 products. There were over 160 JIRA tickets. The software categories kind of surprised us. Instead of just COTS products, GOTS products, and FOSS, they had 12 different categories of software that they looked at. So that was not really apparent in the spreadsheet. It did show up really readily apparent in the graphs. And if you remember, I talked about doing that end of support date cluster with just the year and the month. We ended up having 166 clusters of expiring data or expiring products that, again, was not necessarily visible using the spreadsheet, but then it was using it as a graph. So this shows some of those support clusters. So I have large groupings of products are all expiring or due to expire the same year and month that I need to start working on proactively 6 months to a year out. Same thing with the JIRA tickets. We found mappings, like I said, the JIRA ticket could go to multiple products. You could have a single product with multiple JIRA tickets depending on the environment. So figuring out how those related, and we started finding a lot of things in that area as well, how it was done. This was not without its challenges. Like I said, multiple data sources went into this, and there was a lot of data that honestly was not usable, that we had to figure out how is it being used, is it not being used for decisions. That took a little bit of getting what we refer to as the magic decoder spreadsheet from the contractor to figure out, walk us through, okay, what does this column mean? What are the range of values? How is it being used? Best way to parse the spreadsheet. We looked at, okay, do I take the spreadsheet, do multiple passes since I have multiple nodes? Or do I try to bring everything in one pass? We opted for performance to import everything in a single pass. So that product node got huge with the properties. Then once it was already in a graph and in memory, we could start spinning off the separate nodes based on those property values and then delete the property values from there out of the product node. In the service node, again, we left the end of support date or that date as a property in the product node. However, by using that node with just the year and the month, it made a big difference on how effective we could do it. So if you remember graph engines, graph theory, it costs you a lot to go into a node, dive into the node, go to the next node, dive into the node. So I would have had to hop and go parse every single node to figure out where those clusters are. But by using that end of service date as its own cluster, I can just do a quick hop, 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 and I'm there. I didn't have to hit all the nodes to get that data. So hopefully that answered the question that Charles Campbell had. Did some refactoring of the, I talked about, we were looking at an initial ingest script followed by some sort of update script. The more we looked at it, it would have duplicated the initial ingest script. And so with a little help from the NeoJ community forums, we looked at and put a date created and date updated property on each of those nodes. So when we did a merge operation, so the on set or on create, it would set a date created with the current date. So I know this node and this data was created on this date. If I had seen this already, so it did the on merge side, we did a date updated. So I could start seeing, okay, this has been updated. I have seen this. Oh, I haven't seen this in 6 months. Is this no longer being tracked? So that's by doing those two properties in the nodes, that made it really easy and simplified the scripts, actually. We also, they created on subsequent ingest, we put a new label on the new node. So I can query, give me every node that's new, and it would show me everything that was new that I had not seen previously. And then on subsequent ingest, it deletes that. And then so you've got a steady state. Like I said, the spreadsheet gets updated once a month and provided to the government customer. So that was a way to easily identify what was new since the last time they seen it. And then a lot of documentation, use cases with examples, installation instructions. We also did a Docker YAML file if they wanted to go that route with their installation. So for those of you dabbling in software bill of materials, the data being tracked should sound familiar to you. I started looking at this when the executive order got signed last year by the president as part of the cybersecurity implementation, and they talk about using software bill of materials. So looking at SBOMs, okay, what is it? It's a formal record containing details and supply chain relationships of various components used in building your software. They thought about what are the minimum elements, greater transparency in the supply chain, laid out options for future evolution. This came out of a U.S. Department of Commerce guidance from July of last year, talking about minimum essential elements. So looking at that, and if you read that, somebody, when they came out with that guidance, was thinking about graphs. So this is right out of it. Talks about that and all the topics through it, and this further into the graph will provide more information. Somebody was giving some serious thought to this. And again, it goes further on. It should be noted some of the cases require complete or mostly complete graphs as the ability to not on the network. Somebody's thinking ahead. Again, further in the information, Known unknowns, full dependency graph is not enumerated, must identify the known unknowns, other component relations. This relationship is implied in the SBOM graph structure. So they use the term graph multiple times. Now, the interesting part is a cursory look at the current tools out there that generate a software bill of materials. None of them generate a graph. So because of this work we did with the obsolescence, and there's a strong overlap between the obsolescence fields and the SBOM fields, we've got a candidate for some future research as to importing and ingesting SBOM data to produce similar graphs for some of the customers. And that's it. Are there any questions? I finished early. I don't think we've got our moderator back yet. Let me try here. We talked about digital twins. We talked about the end of support date as a node versus a property. Ethan Surrey, did the transition from relational database spreadsheet to graph technology trigger wider adoption for other use cases? Yes, a little bit. While we were still prototyping this, we got a secondary request to see if it was feasible to analyze their defect reports in Jira. You thought the obsolescence spreadsheet was huge. The Jira tickets that they were tracking in a spreadsheet, again, an export trying to do some analysis on it, it had 164 columns and multiple representations. And we were trying to get them to get out of what I refer to as whack-a-mole mode, for those you remembering the game from a kid. So basically a defect pops up, you smack it. Defect pops up, you smack it. No, start looking at where are my clusters of problems. And we did some prototype for them that unfortunately didn't go any further. But that again is one of the ideas we're looking at is, could we read this out of Jira directly that I'm looking at trying to possibly implement. The graph model, the model is in these slides. So the slides are publicly distributable. I can't go too deep into validity, customer sensitivities on specifically what they're tracking and why. Julius, how do you create / capture relationships from getting spreadsheets into random? So they were not capturing those relationships. That is one problem area that the government was going to have to resolve. Again, we did not want to create a change in the contractor processes that would create a change to the contract. If you go online, a lot of the products, Microsoft, et cetera, if you get into the product, it shows you what things it runs on, or this requires .NET version such and such, or this requires Java version such and such. So some of those would have to be built, and that was some of the use cases we provided them in the documentation. Now that there's an SBOM requirement that's slowly being implemented, that data should be available from a lot of the vendors. Kenneth, it looks like definition of nodes was largely driven by the data that was already there. Is that true? And the relationship? Yes, it was driven by the data that was there. That definitely causes us to think about things a little bit. The relationships, again, part of that was by the data. Part of that was their recurring lesson learned about figuring out what the dependencies are based on learning it the hard way when trying to do an upgrade or a change and it wouldn't work, and they'd figure out there were some dependencies they didn't know about. That was in the documentation and they didn't pick it up. How will I have automatic relationships with the JSON file that I imported? That you'll have to refer to one of the Neo4j folks. I know there's the APOX import and export calls. I believe there are some settings or filters I know on a CSV export. If you export the model or the nodes, then you try to re-import it, it looks for a node file and it looks for a relationships file. And I think that's probably what you're looking for. But you'll have to refer to the documentation further on that one. The Neo4j community can help you out quite a bit with some of those. Are there any other questions?